Hello and thank you for joining me. My name is Russell Trafford-Jones on Broadcast Focus, a channel which looks at the informal side of the broadcast and media industries, trying to look at people and the technology that put it together. And I'm really pleased to introduce you to Gerard Phillips, who's with me today. Hi, Gerard.
Morning, Russell.
Thanks for being here. And what we want to talk about today really is understanding, how you got where you are, because you're with Arista now as a systems engineer. Is that right?
Yeah.
What does that entail?
It entails kind of working with customers and potential customers on their journey to build or refresh an IP-based infrastructure. Most of the guys I work with are in the media vertical, so I work with live production guys, and I try and work out what their problems are and how we can solve those together, or if we can't solve those together, let them know about that.
Mm-hmm. That's cool. And I think what's interesting, and one of the things that I have at the back of my mind is how does anybody kind of navigate getting into the industry, but also where you want to go once you're here. I remember my journey into the industry.
Mm-hmm.
I basically got the job that I wanted to get first time because I didn't have enough imagination to know what could come after that. I said, well, okay, what am I going to do now? So how did you get started? What was your first kind of roles after your education?
Yeah. So my dad was an engineer. He used to work in the RAF fixing radars, and then he worked in the post office,
cool,
building things, and he ended up for a company called De La Rue building cash counting machines and selling cash counting machines. And so I guess I was always going to be an engineer. I mean, my bedroom was full of old resistors and capacitors and transistors, and I was busy trying to build radios and stuff. And when I could afford to from my paper round, I bought a Spectrum, and I had a Spectrum in my bedroom, and I was one of those guys that was buying the magazines and typing all those horrible lines of codes, and my RAM pack fell off the back and didn't work anymore. So I was always going to be an engineer. I did electronic engineering course at Cardiff. I don't think the course was terribly good, but it taught me how to think. Taught me how to do problem solving. So I graduated in '89, and there wasn't a lot around in '89. I ended up went to a careers fair, and I ended up working for a company called Link Miles, who made flight simulators. Ended up in the visual department, and that was brilliant. That was 3 years spent designing PCBs, building things using really old-fashioned technology that people have never heard of today, pals and gals, real gates, and because we're building the visual systems, you would make something, and at the end of the day, you could go into the lab and you could fly around Singapore airport or fly around Hong Kong or whatever you wanted to do. You go and give it a go and see what the visual system did. How did it project the pictures, and did the pictures look like the right ones? And I kind of, they hit hard times. The economy hit hard times. I was made redundant. I got myself a job at GC Marconi, working on the Eurofighter. And after a little while, I really realized I didn't like that. And
what was wrong with it sounds good working on Eurofighter, but what was it that drove you away?
It was very process driven, very formal. When my PCBs came back, I had to go and sign out resistors, individual resistors. I had to, it's all everything has to be follow the process, and everything has to be, what's the right word, auditable, I suppose. So if I change a resistor in a clock driver tree from 220 ohms to 330, I had to go and fill out a form. I had to give the resistor back. I had to go and get a new resistor. My life was too short. And I worked for a project manager who was it was hard work, because we were running late, and his answer to running late was just do less testing. I mean, I didn't design anything to not work right, so I shouldn't have to test anything. So I just didn't like the way it worked. And I had a friend whose cousin, I think, was working at Snell Wilcox in the manufacturing department, and they said, "Oh, they're looking for engineers. Why don't you, they're only up in Petersfield. It's not very far away. Why don't you go have a chat? So you've got a history of video things. So I went and had a chat, and I joined Snell Wilcox in '95, and I loved it. And I realised the thing that I really loved about working at Snell Wilcox was the people, amazing vision, incredible talent, amazing teamwork. The product, the values of the business were good. I mean, we were looking to make products that people really, really needed, that were of amazingly high quality. So I spent 22 years at Snell Wilcox as it evolved from Snell Wilcox, all its various acquisitions and mergers and whatever's. And I left, 22 years later, having built ASICs, having built composite decoders.
So what were you building when you went in, immediately after your defense roles? What kind of things were?
I joined a team. Yeah, I joined a team that was working with IBM to take what at the time was cutting edge deinterlacing and scaling techniques, and to put them into an ASIC. And the aim was to, at the time, an HD. I arrived just as they were doing all their HD products, and an up converter or a down converter would cost many tens of thousands of pounds. And it would be like a 3RU or a 2RU box, and it was just rammed full of FPGAs and discrete logic, and it was, really a huge function. And so we worked with IBM to kind of take that sort of cutting edge, the maths that the algorithm team came out with, amazing polyphase filtering, and we put that into an ASIC. While we're putting into an ASIC, we put a noise reducer into an ASIC. While we're in the world of VHDL and building clever things in ASICs, we built a composite decoder. It's like probably one of the first free running clock, so non-synchronous composite decoders ever built. It was brilliant fun. So the great thing was I was, and it's a thing that's followed me, or I followed, maybe it's the track I followed, is just learning new stuff all the time, working with smart people and learning new stuff all the time. So VHDL was new to me, composite decoding was new to me, simulating all the maths was new to me. It was an incredible learning experience.
It's a big jump from swapping resistors and filling out forms to programming FPGAs.
Yeah. And so I those 22 years were 22 years of constantly learning something new. Every time I thought, I've got to get out of here, I'm getting bored of this. We built something different. I joined a different team. I ran a team. Whatever it happened to be, it was, we took that FPGA and we put it into we take that ASIC and we put it into various products. So we put it into various semi-professional media products. We put it into a box we called the Interpolator, which we tried to sell into the home theater market in the US. So, very high quality decoding, very high quality scaling for use on enormous projectors in LA. So spent some time at fancy kind of CES type shows. Yeah.
So you got around the world as well. Did you end up going trade show to trade show early on?
I didn't get to go to many trade shows early on. As I moved through, I moved into building kind of more broadcast based scalers and deinterlacers from the ASIC we built, and then I moved on to building. I ran the team that built the motion compensated deinterlacer and scaler, the Quasar, which was it could only do up conversion, but it was unbelievably good. So kind of at that time, I started to get to go to some of the trade shows. I also kind of at that time, I ended up not only running a team, but I was responsible for the product management part of the conversion team. So we built a lot of conversion products in all the different form factors that Snell built products in. And because I was running the product management team, I had to go to shows to see what customers wanted. So there was a chunk of my time at Snell where, I was on that treadmill of IBC and AB and all those things. So, but do you know what? One of the things that I also discovered was when I was a kid, I hated the telephone. I hated, because there was a telephone, we shared it with the neighbors. You had to pick this thing up. And the only person I ever talked to on the telephone was Grandma. and she couldn't hear what I was saying, and I wasn't interested in what she was saying, and she wasn't interested in what I was doing. So that I found that quite. I found the telephone stressful, and one of the amazing lessons I learned at Link Miles was, we had to do our PCB work. We designed schematics. Then we had to go and do the layout stuff. It was all bits of paper and stuff. And I discovered that if I just got off my desk and walked across to the drawing office and talked to somebody, or picked the phone up and talked to somebody, magically you were at the top of the queue, and magically your thing, which was important to you but they didn't care about too much, got done. And I think it was a lesson in communication and how people relationships are probably the most important thing you can foster, I think.
Yeah, I understand. Yeah, it's funny you mentioned early on your Spectrum and typing in the type-ins from the magazine. I remember when I had my Amstrad, I typed in probably about 100 lines, all that said sound, and then whatever random parameters I put in, and I played it to my grandma down the phone, and she was very polite, and she put up with it for about 2 minutes of random beeps down the phone, but I was really pleased with it. So
I had a, I mean, I think that was really a formative part of my, process of becoming an engineer, because the Spectrum had this kind of slightly weird memory mapped display system. And so you could go and peek and poke, which was, get and put values into this system memory, which pretty much directly maps straight into the display. So, I spent hours and hours and hours pushing random numbers into random places and seeing that it changed the color of the border, and saw that it changed to something else, or it made the pixel flash, or it didn't have pixels, it had blocks of two colors that flash. So that I really, I think I learned a lot about how much you can achieve if you dig a little bit into the complexities of what is sat underneath the thing that's been presented to you.
Yeah, which of course is everything that you need to be doing when you're doing FPGAs and everything else that came, unbeknownst to you, would come later. So how do you think the technology, how did the technology change over those 22 years? Because obviously it did, and I guess towards the end, which I guess was 7 years ago now, there was a big move to software, or is that still not quite the case? Is there still a large role for other chips?
Yes, I think largely speaking, you're spot on. I mean, it's interesting. I think we talk a lot about the move to the cloud. For the last 7 or 8 years, we talked a lot about the move to the cloud, and I think personally, looking back, we didn't really mean move to the cloud. I think what we meant was move to software. Move away from bespoke bits of hardware with FPGAs and stuff in, and move towards COTS-based servers. And then you can make the choice: did you own that server, or was that server in the cloud? And so, I mean, Moore's law has continued on. Moore's law has been true for way longer than anyone ever thought it'd be true, and it continues to be true. And it's true for both x86s, and for networks, and for GPUs. All those things are still traveling at. I mean, I remember when people talked about the silicon geometries going down to a micron, I thought, that'll be it. Can't ever go beyond a micron. And of course, now we're down to 3 nanometers, right? So these orders of magnitude are, and we don't even, most of the people don't know what a nanometer is, and most people don't know what the thing below a nanometer is. So surely it can't get smaller than a nanometer, but physics keeps going. It's incredible. So I think one of the things that the media, or live production play out has, technology has always been way slower in the live production arena. I mean, the transition from SD to HD. I mean, even the transition from analog to digital, and then SD to widescreen in the UK, and then HD and UHD. I mean, that transition is orders of magnitude slower than the transitions that are now available in software, or made capable by software, compute, networked kit. And I think that's one of the challenges we've got. I mean, some of the kind of institutional parts of the live production world, our industry, are it's tricky. It's tricky to see. It's tricky to kind of match the speed at which some parts of our industry are moving to the speed at which the infrastructure on which we're now building is moving. I mean, as an example, I suppose, back when I was at Snell, we designed, what was TR03 compliant SDI to IP converters, which, my name is on the TR03 spec. I spent a lot of time on that spec with lots of other people, and that morphed into, or was standardized into 2110. But, back then a 10 gig port was a technically difficult thing to achieve for a broadcast company. And 10 gig was way more than we'd ever need, right? And of course, if you look now, there's still a lot of 10 gig based endpoints. But if you look at, current modern networking silicon, 10 gig is, the trends in port speeds in the networking world, which really is data centers and enterprise and campus, is now really heavily weighed towards 100, 400 gig, 25 gig. 10 gig stuff is kind of disappearing away somewhere. So it's, the speed at which the infrastructure can support higher data rates and therefore more agility and more flexibility and more everything else is way quicker than the kind of bespoke products can adapt and evolve to support those. So if, it becomes obvious that if you build your kit out of x86s with network cards, you're going to be able to move down that path quicker. I mean, the whole software, many of the benefits of moving to software are that it's much more agile. You can rebuild stuff in 2 minutes. You can try something out in 2 minutes. You can build new features. You can build on open source. You can focus on the things that are really important to you and your product, and not on, I don't know. I spent years and years and years building a real-time operating system to sit on our conversion products. But I mean, who's got a real-time operating system anymore? Nobody, right? Not necessary anymore.
Yeah, I know what you mean. It reminds me a bit about the of display manufacturers, because they kind of move at their own pace, which is often faster than the broadcast world wants to move. Now, it doesn't mean it's the wrong thing to do. There's consoles out there. There's other ways in which you can get higher resolution, but there's a difficulty in delivering to those screens. But it happens, and similarly, as you're saying, networking continues up to 400, 800 gig, and it's a hassle to split out into 10 gig at that point.
Yeah, I mean, the display story is a really good one. It's a really good analog of or example of where we are. I mean, the display manufacturers used to be driven by the technologies that the broadcasters were using to deliver their content to home users. I mean, we had super huge square, massively deep, CRT monitors forever, and all they had to do was decode a bit of composite out the back of a decoder somewhere, or back out the back of an RF decoder somewhere, and we suddenly got to a point where flat panels turned up, and then the TV industry was being driven by the resolutions and the capabilities of the flat panels rather than the telly guys being driven by what BBC wanted to deliver to your home. So I think all we're seeing is further and further a blooming in that area. I mean, I think we can see it if you look at the kind of the AV market or the pro AV market. I think we continue to see that there's more and more fragmentation. I think possibly, we have 2110, we have, but you very quickly move into kind of other technologies that are available and have different price performance points. And NDI, there's lots and lots and lots of audio formats, and I think audio went IP way before video went IP, because of course the bandwidths were so much lower, and it was you could deliver it without compressing. You only needed a gig network. So the kind of levels of innovation, I suppose, in the audio market, I think, are incredible. And of course, now that you can easily compress stuff in a x86 server, or you can buy an ASIC from China that does it for you, then this kind of move to away from bespoke bits of kit to server-based technologies, or even little NUC-based technologies, is it's quite incredible. And I think having connected it all together with standards-based IP, the we really are in this world where kind of agility and what do I want to do today is almost unlimited.
Audio's if you follow audio and make your predictions based on for video based on what audio's already done, you won't go very far wrong. I remember working on some special events and being pretty astounded at the number of audio endpoints you needed by the time you'd counted up every single language and every single talkback position and all this kind of stuff. And of course, now we're scaling video as well in larger broadcasters to hundreds of thousands of endpoints and things like that. So, whether it's the scale or the technology, we're all getting there in one way or another.
And it's a truism today as it always was. I mean, it's the audio bit that's the complicated bit, right? I mean, if you look at the scale of some of the live production 2110 systems around the world, there's not many. All the big ones are built by organizations that are deploying many languages across many regions, and so of course they've had to move away from a kind of a one video plus a couple of stereo channels. They've got to deliver 8 or 10 languages or something. So the 2110 kind of the ability to the separate elements component of 2110 obviously is a huge benefit there. I mean, you can deliver, how many channels do you need? Just, whack in another multicast and 6 more channels down there. So we're ending up now, when you kind of think about scaling how do I work out what scale I need? You're typically there's not people building 32 channel audio systems, but they could be, right? So you got a video, you got a metadata, there's more metadata standards coming, and then you've got some audio. So you kind of want to think about at least the upper end of the scale being 34, like 32 plus 1 multicast feeds. And the complexity in the control system and the complexity in all the other bits and bobs is about controlling those 32 audio channels. That the rest of it is, it's not simple, but it's way less complex than the audio stuff. Yeah. So I think you're right. I mean, wherever audio goes, once they fix those problems, we can have it for video as well.
Yeah, I think possibly one of the only exceptions in the audio side of things is in live cloud-based production, where you've got that extra latency to get in the cloud, and it doesn't really matter too much for vision mixing. So it's easier to do vision mixing in the cloud, even if you're on the ground. But if you've got your hands on the faders and you've got that extra latency, then it really does cause problems, depending on the type of program you're doing.
Yeah, I mean, but there are solutions to a lot of these things. I mean, if you look at NEP's Andrew's Hub, and some of the other kind of Discovery Eurosports network, these are all kind of, I never really know whether to call it distributed or centralized, because it's both distributed and centralized. But I mean, essentially they're backhauling everything from the sensors back to the data center, and then they're processing it, and then they're pushing it back to the display devices in the remote locations as necessary. I think the feedback I've had from everyone that's done it is that in general, there's a few little bits and bobs that you kind of do locally. That, I mean, most of these people will do some sort of a proxy locally, and sometimes they'll do a local audio proxy. So the feedback, the local audio feedback will be cut by the same commands that are cutting the production audio, but it just doesn't suffer from the audio delay. So I think what we're seeing is adapting workflows to deliver these really quite cool new kind of paradigms in live production, I think. And certainly I'm not seeing that. I mean, every single big system that goes in these days is making another big step in how complex they're looking to build the system based off, somebody looks at Discovery Eurosport and says, wow, that was complicated, and maybe at the time it was painful, but it's working. And now what should we do that's different to that? Oh, let's add in some other complexity. Let's stick an enterprise network over the top of the 2110 network. Let's try that one. So I think we are making some really big steps in the way we build these systems to make them, to really deliver on the promise that IP had when we were all talking about it 10 years ago, which was, flexibility and agility, and I think more connectivity, right? I mean, genuinely genuinely we have native IP connectivity from glass to glass now, if you really try hard. And I think what that means is that connectivity gives you creativity, gives you the ability to have more creativity. You've got more people, can do more things in more places, can reuse the content more easily, can more quickly take that content and repurpose it to something else. So I don't think it's going to stop, to be honest. Whether it's on-prem or not on-prem, I think that train is definitely thundering.
Yeah. And I agree with your point you made earlier about it being software now. Cloud may as well be used interchangeably with software, and I guess it's about the fact that we had to do as an industry what was easy at the time. We feel we need to move to software. Cloud's there. It's a greenfield site as well, which is really handy, so we can build carefully there. And now we've got a little bit more of a nuanced view of being able to understand how to make the workflows work wherever they are, but also the products have to follow. But we wouldn't be able to get there without this move to IP, whether uncompressed or otherwise. So it's building on everything's building on top of each other. So without you coming up with your TRO3, then it would be basically impossible to do what many of us are doing now.
Yeah, and I think it's interesting to think where it's all going to. We hear a lot of people talking about private cloud now, and I sometimes don't really know what they mean, but I think what they mean is an on-prem network. But because we've talked about cloud for a long time, I think as an industry we often use cloud as a metaphor for software. So I think we're going to end up with a lot of flexibility being built into systems. I think one of the things that drove people to the cloud, not drove, but one of the reasons people took the cloud up in the first place was actually, the cloud providers have abstracted a lot of the complexity away. That's kind of one of the attractions is you can spark up a whole load of things and connect them together and run a load of jobs, and you don't have to worry about lots of the complex underlying infrastructure things. And so it allowed people to start to play with what they could do in software and learn how to do some of those things and build some of those things without having to worry about understanding the underlying infrastructure requirements. And I think that's probably been a good thing. I think what it's telling us is that we all have to become a little bit more software. We have to become a little bit more NetOps and DevOps. By that I mean, the job of a broadcast engineer was quite different 10 years ago. And if you step into a cutting edge 2110 or any form of cloud software based live production workflow these days, there's a huge amount of orchestration and automation. And so not only do those guys need to be kind of broadcast workflow experts, they need to know what they need to connect together and how they need to connect it and how the audio works and all that other complicated stuff. They do all now genuinely need to be able to run whatever tool set is orchestrating their cloud workloads, or they need to be able to build a script or a bit of Python to do something clever. I mean, I think the skill set is moving towards being a combined engineering. Well, it's an engineering skill set, but it's a combined broadcast aware skill set with. I don't think you'll survive without some knowledge of how the network works and some knowledge about how scripting works and how you can use a lot of these. So I mean, everything that's half decent out there's got decent API, and so if you can use that API, exactly, a bit of scripting, you can do some incredible stuff.
Yeah, and I think to use the spreadsheet idea as well. I mean, it used to be I've genuinely been in jobs where I've been the useful one because I've been able to use Excel better than everyone else, which is hardly anything to boast about. But nonetheless, you've got to use the tools that are useful. It feels to me increasingly with the size of data you got to put in, now you've got to be able to programmatically get things in and out of spreadsheets and or databases, and for exact reasons like shoving it into an API and finding what the response is. It's another level. It's not necessarily any harder, but again, it's something that you don't necessarily get taught at school, and so got to pick it up somewhere.
I think so, and I think to me it's just problem solving again, right? It's problem solving in a different language, but I think there is a huge resource set out there. So, and a lot of these things are about mindset. So, if you go and have a look on YouTube, go and get yourself a PC, laptop, whatever. It doesn't really matter too much. Learning Python is like the work of about you could learn reasonable basic Python in a half a weekend of looking at YouTube and playing with things. I mean, it's so unbelievably accessible. And whether Python is the thing that you need to use in your job or whether it's something else, the underlying principles of being able to do a bit of relatively simple coding, a bit of object-oriented design, and using a bunch of open source libraries to access APIs is, I think I can't imagine. I think most of the forward-thinking broadcasters are probably looking to be, recruiting people who've got those skill sets, and it's a skill set that you can pick up yourself, I think, very, very easily. And there's so much stuff out there. Python is just an example. There's plenty of other things. Go, whatever you like. There's virtual switches out there. There's you can get free versions of VMware. So you don't or VirtualBox, whatever. There's a ton of virtualization platforms out there that are free. There's a ton of places you can go and get resources to. Well, I'm talking just about networks, right? But I think the thing, it's more wide-reaching than that. So if you wanted to learn Python, I think that's easy. If you wanted to learn how networks work, you could go and build yourself a lab and do that just on a decent laptop. To be honest, there's or a Raspberry Pi. I mean, that's a great, if you can get one these days, you can run PTP on a Raspberry Pi. It's not very accurate, but you can easily teach yourself. What does the protocol look like? How does it work? How do I make it work? Just on a less than $100 worth of cheap and cheerful hardware you stick in the understairs cupboard.
Yeah, I agree. There's a lot of good resources out there, I wonder how much. I go to some places and it feels like the MCR hasn't changed. I'm sure the computers and equipment's updated, but there hasn't really been. It doesn't seem like a very different place. And then, of course, we work with other companies, and they seem fully embedded in working out how to go into the cloud. So every company's at a different point in that journey, I guess, and different parts are often at different points in that journey. So, but I think it's coming.
Well, I mean, I think the other thing that's worth saying is that IP isn't the answer for everybody. I mean,
sure.
If you think about, there's lots and lots and lots of organizations out there who don't need anything more than a 64 squared router, and they're never going to do UHD. So you can argue very easily that SDI is still the right way for them because it's easy, they understand it, the scale's there, it's probably lower cost, it fits with their plans, and it fits with their skill set. So
indeed, they will need API. I mean, APIs and control are still important, and sure, at a smaller scale, then if it's done, it's done, and it's less likely to break as well. And you're going to be messing around with it less, perhaps. So
sure,
I guess that's a good thing there. Thank you, Gerard, for talking to me today. It's been really interesting. How did the flight simulators look back then? Because it's fascinating to me.
Yeah, well, they were huge. I mean, like if you had like a 4-window plane, then there'd be 4 proper rack units worth of compute. Absolutely unbelievable amounts of compute, which of course now you can do that on your laptop with way higher resolution.
And then visually, was it literally just massive polygons, or did it look like? Did you feel it looked like the airports it's supposed to be in?
Yeah, no. I mean, there were tens of thousands of polygons on the screen, so you couldn't really see them. There was
impressive.
We developed a thing we called photo texture, and that was as simple as the ability to to lay photographic pictures over the top of polygons. Before that, it was kind of computer rendered whatever's, different colors or different textures, but it all looked very computery. And so when we kind of had the ability for the database guys to take a photo from somewhere and stick it on the top, that was quite amazing. Yeah.
Wow.
But no, basic compared to what we've got these days. I mean, unbelievably basic.
Sure. But yeah, I don't know. I've seen some VR stuff from back then, and that was super basic. So I don't think you'd want to learn how to fly an airplane with it. Okay, that's great. Really good. Thank you for joining me. Naturally, there is a subscribe button, and given that we're at the beginning of the channel, do us a favor, pop your mouse over the subscribe button, and all will be well. Thank you very much. Would love to speak to you again, Gerard. In the meantime, thanks a lot for joining me.
Thank you very much.